Okay, so I've created this snake game, which took me around half an hour to think about it and develop it. So I'm gonna show you in a short tutorial how you can create your own snake game and just build on top of it. Okay, let's start off by creating a picture box in the form. So to do that, go to your form and open the toolbox and type in picture box. Drag that picture box into the form and make it as big as the form. This is in the picture boxes where we're gonna draw all the information of our snake game. Okay, that's the only thing that you have to do in the designer. Now double click on the form. This will automatically create us the load function from the form. This will be executed whenever the form loads. Okay, so to start off, we're gonna create initially our timer. Timer equal timer, and we'll initialize the timer in the form load. We'll set an interval of 1000, which basically it will tick every 1 second. Timer dot start, we will start the timer counting whenever the form loads, and timer dot tick. This automatically creates us the tick function. At every tick, at every second in our case, this function will be executed, and this is where we're gonna write our entire logic of the snake game. So by starting off, we'll just create a blank screen. We'll draw a blank screen, and to do that we're gonna use two components: a bitmap, which will be equal to the size of the picture box. So if we go here, constructor number 5, it has the width and the height. So we'll do picture box dot width, picture box dot height. So this bitmap, this image, will be of the size of our picture box. Okay, and the whole drawing is done by the graphics class. So create a new object of the graphics and do graphics from image picture, not picture box, bitmap. And by doing this, we basically linked the graphics to the bitmap. Whatever you are drawing into the graphics, it will be displayed in the bitmap. Okay, and let's just call quickly the fill rectangle of the graphic class, and we're gonna use the constructor number 3, which is a brush, the XY position, and then the width height of the rectangle that we want to draw. So we'll do brushes dot let's say gray, and we're gonna start off from position 00. In computers, every time the position 00 is gonna be on top left corner, and the width will be the picture box 1 width and picture box dot height. Okay, that's about it. And finally we'll finish the function with actually putting the bitmap on the picture box. So picture box dot background image equals to the bitmap. Okay, let's just see how that one looks. We're gonna run the program, and we drew a gray rectangle. Actually, we are drawing a gray rectangle every second. Okay, that's perfect. Now what I'm gonna do, I'm just to make it a bit clear, I'm gonna create a draw function where I'm gonna put this whole logic so that we separate the code a bit. Okay, now that we have our background, the rectangle background, we need to start off and draw the cells. To do that, well, we'll keep track of the number of cells in our snake game by doing the creating an integer called the size matrix. We'll initialize that one with 10, so that means we're gonna have 10 cells from left to right and 10 cells from top to bottom. Okay, after the fill rectangle function, we gonna do a for loop which will iterate around the size matrix. Okay, and then a j, which will I will go along the x-axis and the j will go along the y-axis. Okay, okay, let's just do another fill rectangle. In this case, we're gonna draw a white rectangle for each separate cell, and the start position is gonna be I multiply by the width divided by size dot matrix. So basically the number of pixels each cell will have. Done that right? Okay, and the same for j. And we're gonna do the same thing for the width and the same thing for the height. Okay, perfect. And if we're gonna run that one, now it just throws a white because we didn't put any space whatsoever between the cells. To fix that issue, we, instead of drawing exactly from the starting from this position, I multiply the number of pixels of the cell. I'm gonna add a 1 in here, a 1 in here as well, and we're gonna subtract a 2 and the 2 from the width and height of the cell. And that's it. Okay, we've done something wrong. Yeah, I forgot to change this one to height, this one to height. Okay, perfect. Now we have 10 cells from left to right and 10 cells from top to bottom. Cool. To make this a bit nicer, okay, so to make this one nicer, we're gonna initialize a size object called the size of the cell, size cell, which will contain the size from here. So the width will be that and the height will be that one. Perfect. And then we can just replace this whole thing with the size cell dot width, and this one with the size cell dot height. Okay, perfect. Now we should have the same result. All right. at the right and bottom you can see there's some extra stuff in there, and the problem in here is because in fact our size is integers and it's not a float value. So to fix that we just gonna initialize a size f, which is basically it can have decimal points. And in here you can see that it already started using the right constructor, in this case the float, the one that contains floats. Okay, yeah, there's still some issue. Another thing that you need to do, because these are just integers, this divided by this, two integers divided with each other will result in another integer. So to make them not lose the decimal points, we're just gonna convert one of them to a float. Okay, perfect. Now the way I was thinking to make the snake game is to create this matrix which will have the value 0 if there's nothing in there, and it will have the value 1 if it's the head of the snake, and the value 2 if this is second segment of the snake, and so on. So to do that we're gonna have a new integer called matrix, which will have the size of new integer of size matrix. Okay, perfect. And just let's create a new function called initialize. That will be called in here initialize. What I've done, initialize here, where we're gonna do our first initialization of the snake game, and in this case we're just gonna put at position, let's say 5 5 the head, and at position 5 x y let's just make it horizontal, so it's gonna be 6 and 7, 2 and 3. So now we're gonna have our head, basically its head's gonna point to the left, and the body is just horizontal. And to draw that snake we're gonna go back in our draw function, and we'll have to check the matrix before drawing this whole thing. So if the matrix of ij is equal to 0, we're gonna draw this. Else we're gonna draw the same thing, but this time let's just use the color blue for the body of the snake. Run this, and now you can see the snake. Our snake is starting to come alive. Okay, perfect. In the scene I was thinking to also add a food for now, maybe some spikes afterwards, and because we are already using the number 0 for nothing and positive numbers for the body of the snake, we're gonna use the negative numbers for any special objects. In this case I'm gonna use the number -1 for the food. And to easily do that, so that we remember afterwards, I mean not to remember, to not have to remember the numbers, what each number stands for, we're gonna create an enum which will contain all the possible objects from the scene. So in this case we're gonna call this one let's just say matrix object, and for food we're gonna give the value -1. Maybe for spike we're gonna give -2, and in the initialization let's just add the food somewhere at position 2 and say matrix object dot food. So basically this is just a 1 added to the matrix, and we also have to convert this one to an integer. Okay. Okay, let's also draw the food. So to do that we're gonna do another if statement, which will compare the matrix to the matrix object dot food, and we're gonna use the same function and draw a red cell in this case. Make this one an integer. Okay. Let me just see, I'm done something wrong. Okay, yeah. So this is 0, is food. Okay, I forgot an else if. Okay, perfect. Okay, now let's make our snake move and do more interesting stuff. Also was thinking to change the size matrix to 20 because then it looks just too small. And when we already done an enum for the matrix objects, let's do another enum for the snake direction. Which will be just let's start from the top, so up, right, down, and left. Okay, if you don't give them any value whatsoever, they will just pick up as 0, 1, 2, and 3, and so on. Okay, okay. For the movement on the snake, we're gonna create a new function called gameLogic, and this will be called at every tick. And the way I was thinking is that we will loop through the entire matrix, and whenever we see the positive number, we will increase that one by 1. So basically 1 becomes 2, 2 becomes 3, 3 becomes 4, and so on. So for that we'll copy this for loop, and we'll check if the matrix is a positive number, if the value of the matrix is a positive number. If it is, then we're gonna do matrix of ij plus plus. Okay, if it's bigger than 0, actually we'll have to do this one if it's bigger than 1, else if matrix is equal to 1, because remember 1 is our head. For head we have to do something more special, and in that case we'll have to move it to the left, right, up or down position. And but now we don't really know where the snake is facing, so let's just create a snake direction called let's just say snake direction, and let's make it face to the left hand side. So in the initialize, we'll do snake direction on left hand side. Okay, now in here we can use the switch statements, and depending on where the snake is facing, we'll move it to that position in the cell. So if the snake direction is left, we'll do something basic, and in that case we'll do matrix of ij. I forgot the column in there. ij minus 1 equals to 1, and we'll have to do the same thing for the rest of the directions. So actually let's just start again with up, right, down, and left. For left, that's already done. For up, we're gonna do j minus 1. For right, we're gonna do I plus 1. And for down, we're gonna do j plus 1. Okay, perfect. And at the same time, actually we also need this one in here. Let's see how it behaves. Okay, perfect. It goes to the left. The only problem is that it crashes whenever it gets to the edge, and we are not removing any old segments. To do that, we'll create a new integer called, let's say, last segment. And in last segment will be of value 3, because we have 3 segments. And in here, whenever the matrix is greater than 1, we'll have to increment it, but if the matrix is equal to the last segment, we'll have to set this one to 0. Okay, perfect. Okay, now let's just add some movement. To do that, actually there's another thing that we need to do in the designer. You go back in the designer and go at the events. You will have somewhere, yeah, the key press event. Just double click that and it will automatically create a function for you. This function is gonna is gonna be called whenever you are pressing something on the form. So any key on the desktop, on any, so this function will be called whenever you press something on your keyboard while the form is focused. And for that case, we do a switch of the key character that's gonna be pressed, and we're gonna have 4 different possibilities. So that will be the W, D, S and A respectively for the direction of snake. And all we have to do is change the snake's direction to up, right, down, and left. Okay, let's see how that works. Okay, now the snake goes okay, so I was getting an error and yeah, I found out what was the issue. So whenever the head moves, we'll have to register that the head was moved, otherwise it will just, because we are still looping through all the metrics after we've created this extra head, it may or may not be picked up afterwards again in the for loop, and that will cause the head to move again and again and again and again in the same game tick. So we don't really want to do that. So what we're gonna do is gonna create a boolean here called head moved. We'll initially call it make it false, and this one will also have to be that we haven't moved the head yet, and we're gonna mark that one as true. Okay, perfect. And we've ate the food, but yeah, the body didn't increase, and the food didn't appear in a different place, so we're gonna fix that one. To increase the body size, all we have to do is whenever we've ate the food, so if for example if when we need to move to that position in the matrix, when the head moves in the position of the food, so matrix of ij equal to matrix object dot food, we're gonna increase the segment size, I believe it's called, segment to, well, what it was plus 1. Okay, and when that's done, we also have to generate the food in a different position. So we create a new function called generate food, and all this one is gonna do is gonna create two new numbers, an x position and a y position, somewhere on the plane. And because we want that one to be random, we're gonna use the random object. Just let's initialize this one as new random. And in this function we'll have a point called food generated, food or food position, and its position is gonna be a new random number, which will be somewhere between 0 and the size of the matrix for x and y as well. Okay, but when we generate this food, it should not be placed somewhere where the snake is, because, well, that would cause some issues. So to do that, we'll have to check, we'll have in fact to generate a new position every time until the food position, until the matrix of food position dot x and food position dot y is different of 0. When we found a position that is 0, that means we found a free position. And after that's done, we can easily put our food into that position. Okay, perfect. Almost perfect. Convert that to an int, and we'll have to generate this food. Well, in fact, we can generate it when we initialize it, so we don't have a hard-coded position, hard-coded initial position, and whenever it increases the last segment. Okay, it did not generate a new food and it did not increase the size of the snake, so that's quite bad. Okay, so the issue is that in fact this is not the what we are checking here is not the position of the snake, but it needs to be the position of the food, which will be the direction where our snake's gonna move. So to fix that, we'll have to find out in which direction it moves first. So we'll just put this one in here, and let's just create a new point in here and say walk position, and the walk position is gonna be a new point similar to this one. Just trying to clean up the code a bit as well. So walk position, this, this, and this. Okay, don't need this anymore because we're just gonna do a matrix dot, not matrix of walk position dot x and walk position dot y equal to 1, and we, what the hell, use of unassigned variable. Yeah, to fix this issue we're just gonna throw an error. Default throw new exception, and let's just say that it is not possible for the snake to not have a direction. Okay, perfect. And we'll have to check this one in here. So if the position where the snake's gonna move has a food, we will increase the last segment and we'll also generate a new food. Oh god damn it, I should have this far away. It okay, it increased the size of the snake, although it increased later on, unfortunately. Okay, yeah. So the problem of the snake being increased sometimes afterwards is because whenever we're increasing the last segment, we may already have removed the last segment, basically, to actually catch up with the new increase of size. That's only is gonna happen in the next tick. Refactor a bit and run the code of the snake head firstly, and then run the code of the other stuff, basically. Yeah, actually, let's just do that. For that, we'll have to create a point called head position, and just do head position equal to the 5 Okay, and yeah, okay, we can actually just remove this whole stuff and put it at the beginning. We don't need this bit of code, we don't need the head moved anymore in this fact, and we're just gonna say head position. So we'll take this one, so we're gonna just put head position dot x, and whenever we have an I, no, head position x, head position x, head position x, and head position y in the j position. Okay, for this case we are just gonna run initially the code for the head, and then we're gonna run the code for the rest of the body. Yeah, and this one in here as well. And we'll also change the head position to the walk position, which is quite nice that we can directly use that variable. Another issue now, kind of decrease the size of the last segment. Let's see what we've done wrong. Okay, at least the food collection still works fine. Bam, perfect. Now the issue that we have is that if we press W, which will turn it around, just does weird thing. To fix that, we should not allow the user to turn back into tail, basically. So snake position, snake direction. So if the current direction of the snake is equal to down, then we'll break. Or actually, it looks nicer if we do that. Okay, let's just do this to all of them. So down, up, right, left, down, up, and left, right. Okay, now I cannot go back, I cannot go up, I cannot go left, and yeah, I cannot go up. Okay, now let's make it, well, kill itself. It, for example, hits the tail. So that can be easily done. So walk position, if walk position is food, else if walk position is bigger than 0, just say initialize. So we'll initialize our screen again. Yeah, well, if that's it. So we eat our tail. Let me just, oops, actually for that matter, let's make it loose even if we run into walls. So if that, okay, so what we can do is actually put this one here. We don't really need an else. Okay, let's forget the return. Or if walk position x smaller than 0, or walk position dot y smaller than 0, or walk position x bigger than or actually equal to the size of the matrix, or basically when it's equal to the size of the matrix, we are out of boundaries. Walk position dot y size of the matrix. So if that happens, yeah, well, we'll have to check for this stuff initially, and then go to that one. Okay, a lot of weird stuff happened. Yeah, I did amend that. So yeah, with the initialize, we'll also have to clear the screen initially. So we'll just take this for loop. Okay, perfect. And let's just do this. Perfect. As you can see, whenever we hit the wall, it restarts the game. And if we hit our tail, that also restarts the game. But this is one option to make the snake game. There's plenty other options to make it a bit nicer. So for example, if it hits the wall, instead of just dying, you could make it appear to the other side of the screen. That's fairly easy. So you will have to play a bit with the walk position. So you will have to check this stuff in here as well and see if it's out of boundaries. If it's out of boundaries, you will assign a different value to the walk position, which usually it's be either x or y will be 0, or the size of the matrix. So if it, for example, if it breaks this boundary, then you will set the walk position to the opposite of of 0, which is size matrix. Or if it broke these boundaries, you'll have to set the y position the opposite of size matrix, which is 0 in this case. And that's about it. Okay, well, thank you very much for watching, and let me know if you want me to create a tutorial for another video game, another simple video game like this one, so something like the tic-tac-toe or the minesweeper or anything else that you can think of, Tetris maybe. Just let me know down in the comment section, and yeah, see you next time.